Hey, what's happening, guys? Just sitting here looking at the Arduino and thinking, man, what if this had existed when I was a kid? A kid at the right age. Say this thing had come into existence somewhere between 1978 and 1982. Would have been, I'd have been between what? 9 and 12 years old or something at that point. And at that age, this would have been an incredible piece of technology to have. I mean, we had some technology. We had Heathkit back then, which was super fun. But an Arduino. So I'm sitting here trying to think of what would be an interesting Arduino project that we could do. Start simple and expand it. I had an idea for a simple start. And then I was talking to my friend Barry in Florida, and he got an idea for me for the rest of it. So here's my thoughts. How can we take an Arduino with no sensors, because obviously you can do just about anything you want with sensors. How can we, using nothing but the Arduino and resistors, make an Arduino Ohm meter? How could we do that? So let's say this is an unknown value resistor. What could we do? Well, let me get some jumper wires here. Let's say if we took 5 volts, there's 5 volts there, and we'll bring that over here. Now, the Arduino can only read one thing, really, voltage. Yeah, I mean, it can look for an on-off signal, high-low, 5 volt, 0 volt, true, false on the digital pins, but on the analog pins it can really only read voltage. So we're going to need to use Ohm's law. Ohm's law, is a triangle. There are 3 things: voltage, current, and resistance. If you know any 2, you can figure out the third. So we know the voltage, 5 volts. So we could put this in here, right, and read the current across it. No, not really. The Arduino doesn't have a way to read the current. It can only read voltage. So we could read the voltage drop across that. Yes. But then we don't really know the current, do we? Here's what we need to do. This is our unknown resistor. We need a known value resistor. So here we have 10K. And don't worry, we're going to measure it to know exactly what it is. But for now, there is a 10K resistor. So if we take our 10K resistor and put it with our 5 volts, so we get 5 volts through the 10K resistor. And then we take our unknown resistor and put it to ground. And we will need a connection to ground. So there's a ground right there. So if we take then another wire and we put it at the junction where we've created this voltage divider, and then bring that wire back to one of the analog pins. My wire's not long enough. We'll have to reconfigure things on the board. But let's say we plug that into analog 0. Well, now we have 2 sides of the triangle, and we can figure out the third. So what's next? Well, let's configure this better. All right, so here's our reconfiguration. I've taken 5 volts here from the 5-volt pin, put it up here. Ground is down here to our ground rail, and then I brought a ground rail up to the top so we have it when we need it. We have our OLED power and ground up here. Uh-oh. I'm going to plug that one in the wrong hole. And then we have our data and clock coming over here. We have our known resistor, the 1K resistor, coming from our 5-volt rail, creating a voltage divider with our unknown resistor, which is going to ground. Then we have that pin going back to analog 0 so that we can take it and read the voltage value. Now we will be able to figure this out. Let's first get a reading on our known resistor so we know exactly what we're dealing with. Nope. That's what always happens. These things snap off on. Look at that. And we lost the entire resistor. Let's try it again. This time maybe we'll sit it down. Perhaps we should sit it down first. This is a real... I launched it again. Okay. Okay. Apparently we're going to need another one because that one's now in orbit somewhere. No. That's 100K. Here's our 1K. All right, we'll try it without bending the leads this time, see if that makes any difference whatsoever. God, this does not want to stay on there. Okay. So our reading is 0.974K or 974 ohms. Let me get a Kugelschreiber. A piece of paper would be good too. 974. Okay, let's go and write some code for this. All right, here is our sketch, and I modified this code. The original was by a gentleman named Isonis Christolakis. Sounds like a nice Irish boy. All right, so on we go. We start out with the wire library, which we need for the I2C. Then we also need the divider library, or display library, so we can have a display. This line here just has something to do with the display. It needs reset to be on pin 4. I don't know why, but it does. Then we set up our display, the SSD 1306, and we give it a name, and that name is display, and that's how it'll be referred to from now on. Then we need to set up some variables. An integer called analog pin. You're going to want to run your wire from the voltage divider to wherever this is. In this case, it's 0. You could change it. It doesn't matter. Next, we have our raw value. That is the reading from the pin. That's just an initial value. We'll set it for 0. Now we have VN. You know, your Arduino puts out 5 volts at the 5-volt pin, so that's what we're using. If you want to be pedantic about it, you could measure it and maybe you'll get 4.973521. But for this case, 5 volts is close enough. Now we need some floaty values because this is where we're going to do our calculations. Our voltage out. R1, which is our known value. Remember, we measured that resistor at 974 ohms. And R2, which is going to be the unknown resistor. And also, we're going to create a buffer that we can put some stuff into. It's just a reusable variable. All right, we have our setup. We're going to start the display. Display begin. Then we're going to show what's in the buffer. Wait 2 milliseconds because I don't really care. And then clear the display. Now everything's good to go. All right, so here is the loop. This is the main logic of the program. This is how it works. So we're going to have that raw value we use. That's going to be an analog read of the analog pin, which is pin 0. And if it gets any reading, we're going to put the raw value times V in into the buffer. So that is now our voltage divider reading. Now our voltage out is going to be the buffer, which is our voltage divider reading, divided by 1024. That will give us an actual voltage as opposed to a number from 1 to 24. Now in our buffer, we're going to do V in divided by V out minus 1, which is kind of the voltage divider equation, but not exactly. That would be R2 divided by R1 plus R2. But this is close enough for our purposes here. And then R2 will equal R1 times the buffer. That's our unknown value is our known value times what's in the buffer. And then we'll just display it and wait a second and do the whole thing again. Don't worry, I'll put a link to this code down below. You can copy it and do what you want with it. All right, so here's our code running. I don't know how well you can see that, but it says V out equals 2.5 volts. So R2 is 974 ohms. That's right. I used another 1K resistor in there. So I brought a sampling of resistors for us. Let's try something different. They're all stuck together. Pardon me. All right, here is 220K. So we'll pull out our unknown. And we'll put in the new unknown. That's not right. Not even close. All right, let's try something else. We'll take out the 220K. We'll just set it up there for now. Let's get something closer to 1K. Here's 20K. Let's see how 20K does. I think I'm onto something here. I'm sure some of you guys have already figured it out. 20K is showing me 50. All right, let's see if we got something smaller. Give me a second here to find a smaller one. All right, here's 510 ohms. Nah, it's not even close. Okay. So I think we're going to have to do two things. We're going to have to increase the top one, I think. Not quite sure. Now, if I put in that one, we get close enough. So it's right on at a 50-50 split. Maybe I screwed up my voltage divider equation. That is entirely possible. Here is 750K. We don't want that much. Looking for an R. 10R, 820, 680. All right, how about 820R? Let's see how that one does. Let's just reset that. 820 showing up 1166. Confusion sets in. I think the problem is the unknown resistor should be on top. and I was completely backwards. Let's find out. So we're back with our 974 ohm resistor. Pop that guy out. Let's put in 510. See what we get. There we go. So the Arduino is giving us a reading of 505.79. We'll call it 506. Let's see what the actual reading is. That's like, I know in theory this should work. I know it should. I did the math. 506. Dude, that's like 100% accuracy for that range. All right, so let's try 820. Kind of idiot puts his voltage divider together backwards. I'll tell you what kind of idiot. This kind. 820 showing 810. I'm happy with that. Now, let's go for a bigger value. 220 ohms. What do we get for 220? I'll tell you what we get. A train. Yeah, 220's off pretty far. Let's go with trying to find something. Come on. All right, here's pretty low. Here's 47 ohms. Let's see how it does on pretty low. After the train, of course. All right. So there's 47. Yeah, it's pretty good. So I would say, well, we need to find a high end. Let's try 100K. See how it handles 100. We know 220 is too much. Here's 100. Let's see how it does with that. What the hell does it say? 123. Now it says, yeah, 1, 2, 3, 6, 9. Yeah, see that? Okay, so that's too far. I'm trying to find like a 50K. Hang on. There we go. 50K. 51 actually. Let's see what we get out of that. Then we'll have a better idea. $57. All right, let's see what its actual reading is. Yeah, it's damn close. Okay, so here are my thoughts. You've got to be within a certain range of the unknown resistor, or it's not going to work. There's a way to make this work, but I don't know the programming of it because I'm not a programmer. And that's why I want your help. What if we set up an array of known resistors? Let's say 100 ohms, 1K, 100K, and a meg. Just for instancing here, just spitballing. And we switch the read through them. But how would we know which one's more accurate? See, this is where I'm lost with programming. How would a multimeter do it? That's where I need your help. If you've got an idea, put it in the comments. If you can write the whole code, email me. But let me know what your thoughts are on this, because I think this is a neat little project You don't have to use an OLED if you don't have one. You can display this right on the serial monitor or an LCD, you know, whatever kind of display you have. But I think it's pretty cool. I hope you enjoyed it. If you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons, and a big thanks to you for watching. That's it. I'm out. Peace.